Welcome back. So today we are going to discuss about orbitals, right? And we'll discuss the more about the orbital shape, size, how to do the electronic configuration and all that. So when I'm saying orbitals, so actually we are going in exact location. We have talked about shell, right? We have gone to the shell, then we have gone inside the cell and we have seen subcells, right? And still again we are going inside the subcells to find the exact location of the electrons, that is orbitals, right? So here we are right now. So we are in the exact location where we can get the electrons. So in this section we will talk about the how orbitals look like, what are the shapes, right, and how we can uh, name the shape and how many electrons they have. Everything we will discuss in this particular section. So before going into the detail of this orbitals, let's talk about what orbital is and what the specific energies they have and how they look like. So actually orbitals are present within the subcells. So we can say that subcells contain the subcell contains one or more orbitals. Fine. So, and these orbitals have a specific energy, and the electrons can only be found at these specific levels, not in between. So, right? So we can say so each atomic orbitals can be occupied by maximum of two electrons. So we can say each orbital contains, or you can say may occupy, max two electrons, not more than that, right? And there are shapes. If I'm going to talk about the shapes of orbitals, right? So we have multiple shapes. Before that, let me tell you, each orbital have specific energy level. So specific energy. So the electrons which are present in these orbitals, they have a fixed energy. Let's say if I'm saying electron is present in s orbital, so they have different energy as compared to p, as compared to d, right? So you must understand that orbital exists at specific energy level, and electrons can only be found at these specific level, right? So let me write a key point here, that orbitals exist at specific energy level, right, levels, and electrons can only be found at these specific levels, not in between. This is the important point. So s have a spherical shape, right? P have dumbbell shape, D have double dumbbell shape like this, right? So these are different shapes and all are in 3D form, and you will get these shapes are already given in the d- in the data booklet. And the most important which is required here is S and P. This d orbital shape not needed in your syllabus for DP Chem. So you don't have to worry about the D shapes, right? But let me tell you, when I'm saying S, there is one orbital, right? If I'm saying P, P have three orbitals, right? So each orbitals have two electrons. It is filled like this, right? So there are two electrons. So I can say here that each orbitals contain max two electrons, not more than that. So here you can, if you remember, we have seen S contain two electrons, P contains six electrons. So there are three orbitals, right? And each have two. That means total six electrons. This is how the shapes are conveyed. If you will, if you'll see the further shape of these p orbitals, let me take you through the. So there are three shapes of these p orbitals. P orbitals. So let's say we can find p orbitals only in next shell, shell number two. So right. So we can. Uh, so let's say there is a px, py, and pz. This is the orientation. So this is x-axis, this is y-axis, right? Let me show you where these are. So x-axis, this is the p orbitals, px, this is px, this is py, and the pz is exactly at the this location, right? So this is how the electrons are, I mean the orbitals are arranged. So we have understood the shapes, and s orbitals have a spherical shape, right? So these are the shapes. So the questions based on the shape, you can say this is s orbital, and there is 3p, x, py, and pz orbital shapes. Now let's go to the next section. Now when it comes to the ground state, let's talk about what is ground state and how the stability is maintained in an atom. So always remember one thing: energy is inversely proportional to stability. Always remember, if you have more energy, you are less stable, right? Let's say, take an example, if you have a more money, so you have lots of ideas in your mind to invest it, right? So your mind will be unstable in the sense like right now you are thinking to take this, then suddenly you will think to go and do that, buy this, buy that, eat this one, eat that one. So you will keep on thinking, so your stability will be more. So more energy, that is less stability. Vice versa, less energy, more stability. So let's think about what is happening at the ground state. So the ground state is the most stable electronic configuration, right? Because atom which has the lowest amount of energy, so they have more stability. We can say that the ground state is the most stable electronic configuration of an atom which has the lowest amount of energy. And that's what Aufbau principle follows. So this is how we can achieve this. So this is achieved by filling the subshell of energy with the lowest energy first. That means from 1s. And this is called Aufbau principle, right? So the order of the subcells in terms of increasing energy does not follow the regular pattern. Like if you'll see the order in which the electrons are filled in an atom, you will find that order is starting with 1s, then it goes to 2s. After that, the electrons, if you have left, it will go to 2p, then it will go to 3s, then it goes to 3p. From 3p, it goes to 4s, and then from 4s, it goes back to 3p, sorry, 3d actually, right? It goes to 3d, then from 3d, it goes to 4p, and then like this, it will keep on going. So, so what we have understood here that the electrons will be first filled. Let's say, let's take an example of, let's say you want to fill an electron in an atom. Okay, let me give you an example. Suppose you have to fill an electron in carbon. Carbon have 6 electrons, right? So we write 1s2, 2s2, and then 3p2. Why 2? Because there's a total 6 electron. So this one shows number of shell. This is subshell, and on the top it shows number of electron, right? Let's say take an example, oxygen. Oxygen has 8 electrons, so it will be 1s2, 2s2, 2p4, right? So number of shells, or you can say principal quantum number, or quantum, or quantum, or principal quantum shell, right? So the principal quantum number shell increases in an energy with increase in principal quantum number. Example, n is equal to 4 is higher than energy than n equal to 2. So you have to remember that the principal quantum shell increases in energy with increasing with increasing principal quantum number. Let's take an example. Uh, Let me go up. So examples like, let's say, if I'm to compare n is equal to 4. So it's 4 is at outer side of the shell, right? So n4 is higher in energy than n is equal to 2. So so the subcells increases in energy with the order of like this. So you have to remember that the subcell increases or increase in energy as follows. So first S, then P, then D, then F, like this. The only exception, you will find one exception also, that 4s orbital have slightly higher than 3D. So I will write the exception here. What is the exception? Exception is that the 3D have slightly higher energy than 4s. That's the reason 4s filled before 3D. So 4s is filled before 3D. That's the reason. So as we have seen that each subshells have a shell, right? So let's check in a tabulated form how these shells are, right? So each cell, each subcell, let's discuss about each shell can be divided into subcell, right? Like S, P, D, and F, and each subcell hold a specific number of orbitals, right? So as I have discussed earlier, so let me tell you, if I'm going to say S subcell, they have one orbitals. P subcell, three orbitals. And we have just now seen the shape px, py, pz. D subcell have five orbitals. Five orbitals. And F subcells have seven orbitals. And if we can check with the number of electrons they carry, you can easily find out. So in case of each orbitals have two, so it will be two electron will go here. In case of P, there are there are three orbitals and each have two, so it will come around total six electrons. Here you have five orbitals each have 10 electrons, right? And here you have 14 electrons, right? So this is how the shapes are and orbitals are arranged. So in the next lesson, we'll discuss about the electronic configuration from atomic number 1 to 30. And we'll also discuss which electronic configuration is important and why. See you in the next lesson.